Hello, my name is Humphrey and I am here to present how to find the derivative of a certain equation. And afterwards we will find the antiderivative of that derivative, which is just the same as finding the original equation. So let's start. Given that f of x is equal to 3x cubed plus 4x squared minus 5x plus 1 over x squared, we are tasked to find the derivative of this equation. Simply, when we state that the derivative of a certain equation, we can just say that f prime of x. Then, first thing to do is to identify what formula should we use in order throughout solving the equation. I have decided myself that I will use the power rule, in which it states that d over dx, or the derivative of a certain term raised to the power of n is equals to, you will bring down n and you will multiply it to the term or the numerical coefficient of the term, and then you will subtract 1 from the exponent. So as you can see, it can apply on all of the terms but not the last one. So we'll just find out a way on how we can apply this formula into the last term. First thing is, the first term is 3x cubed. So we bring down 3, then multiply it by our numerical coefficient, which is 3. Then we subtract 1 from x cubed is equals to x squared. Next is the 4x squared. We bring down 2, multiplied by the numerical coefficient 4, and we subtract 1 from the exponent x. And the next is 5x. As you can see, there is no number in the exponent. In math, when we see this term, it can be automatically stated that an exponent is existing right here, and can also be not written. So we bring down 1, then multiplied by negative 5 is just negative 5. X 1 minus 1 is 0. So any number, any term raised to the power of 0 is just 1. So 1 multiplied by negative 5, that's negative 5, and multiplied again by 1 is still negative 5. Then the last term. We know that we cannot apply power rule on this term because it's a fraction. So what do? Is we can move the denominator towards the numerator, and that term could be called as x raised to the power of negative 2. 1 over x squared is just equals to x raised to the power of negative 2. So x raised to the power of negative 2, we bring down negative 2 plus negative 2, and then multiply it by x, and we subtract 1 from negative 2, which is negative 3. Afterwards, we simplify. 3 multiplied by 3 is 9. Multiplied by x squared is 9x squared. Plus 2 multiplied by 4 multiplied by x, that's 8x. Simply copy negative 5 rather. Then finally is to multiply the last term, negative 2 times x raised to the power of negative 3. So we can see that x minus 2 is equals to 1 over x squared. So we can also state that x raised to the power of negative 3 is also equals to 1 over x cubed. Negative 2 multiplied by 1 over x cubed, that's negative 2 over x cubed. And that is the derivative of the equation. Now, before we end the session, we will find the antiderivative of the derivative of this formula. So it is stated also, we already know that the derivative of the formula or the equation is 9x squared plus 8x minus 5 minus 2 over x cubed Now we will find the antiderivative of this equation. So I also have decided that I will only use a single formula that states the antiderivative of any term raised to the power of n is just equals to x raised to the power of n plus 1. Then you put the n on the denominator and then add 1. So in here we can simply state that f of x, or the derivative of this equation, and the antiderivative of 9x squared plus 8x minus 5 minus 2 over x cubed. Now, to simplify everything, we need to chop this down into parts. So the antiderivative of 9x squared plus the antiderivative of 8x minus the antiderivative of 5 minus the antiderivative of 2 over x cubed. Then we simply apply each one of them. So we bring out the numerical coefficient, then the antiderivative of x squared plus 1 over 2 plus 1. Then again we bring out the numerical coefficient, then the antiderivative of x. As stated earlier, that when we cannot see any numerical coefficient on the exponent, that is considered that there is a 1 existing in there. So 1 plus 1 over 1 plus 1. The next is 5. And to find the antiderivative of 5, that's equals to x 0 plus 1 over 0 plus 1. Why can we say that there is an x over raised to the power of 0 and we can add 1? Well, in the previous part, we subtracted 1 from 5x. We subtracted from the exponent of x and it became 1. X became 1. So we can also state that x in 5 is just equals to x raised to the power of 0. So we add 1. Then lastly is this term. So we can see that on the last term we cannot apply this certain formula. So what do we do now is we move or we bring back again the denominator towards the numerator, and as stated previously, 1 over x cubed is just equals to x raised to the power of negative 3. With that said, we can easily bring out negative 2. Then the antiderivative of x minus raised to the power of negative 3 plus 1 over negative 3 plus 1. Now everything we need to simplify. So 9 times x raised to the power of 2 plus 1, that's x cubed, over 2 plus 1 is 3. Later on we will simplify everything else. I forgot something, that in this equation, when we will find an antiderivative of certain equation, we should add plus c, or a constant, because the constant itself will appear when we will find later on the original equation. Then next is 8 multiplied by x raised to the power of 1 plus 1, that's 8x squared, over 1 plus 1 is 2, minus 5 times x raised to the power of 1 over 1, that's equals to 5x, minus 2 raised to the power of negative 2 multiplied by x raised to the power of negative 2 over negative 2. Then to simplify everything up, that's cancel this out, that's 3x cubed Then we can also cancel this one out. That's 4x squared minus 5x. Then finally we can cancel this one, and we can bring back or bring down back x raised to the power of negative 2. So that's equals to, after canceling this one, we can consider this term as positive, so that's 1 over x squared. Then finally add c, or the constant, plus c. So to rewrite everything, that's the f of x, or the antiderivative of this equation, is equals to 3x cubed plus 4x squared minus 5x plus 1/2 1 over x is power of 2 plus c.